Hello, it's Dr. Naiman again. We're up to video 4 on the lecture series, and we're still right in the thick of it with the p-value. So uh, you think you might know what the p-value is, but can you articulate what a p-value actually means? And I think there's a lot of misconceptions surrounding what a p-value actually means. And it's not that, and definitely not that, and no, and good luck with that. And a lot of people think, oh well, that scratch their head. That sounds correct, but it's not. Basically, a p-value is that you're a probability that the results you have got could have happened by chance alone, as opposed to a systematic effect from the um, factor of interest. And 0.05 is essentially an arbitrary cutoff. There's nothing magical about it. It's just something we all came together and agreed that this is where we draw the line. This is statistically significant, and everything higher than it is not statistically significant. But what that means is if you take 20 papers that report a p-value of around 0.05, one of them describes a cause that has no relation to the purported effect. And I'm just going to repeat it because it's important. For every 20 papers that report a p-value of 0.05, one of them describes a cause that has no relation to the purported effect. So why can't we be certain that chance isn't causing the result? So statistics is the science of taking a small representative population and applying an observed phenomenon from the subset to the whole set. Basically, you extrapolate, but it depends on how representative it is and how big your sample size is. You can't flip a coin infinite number of times to prove conclusively that it's 50-50 chance of heads or tails. So you can't prove a coin is fair. You can only flip it 100 times and say that's good enough. It probably is fair. Likewise, you can't test the entire population of the planet, only a small group of them. So yes, this is probably everybody's reaction to this, and we're not going to get too much into the weeds in it, but there are many different tests that will all come up with a p-value. And a p-value isn't something about the test. A p-value is, once again, the probability that you got the results based on chance alone. So every statistics measure essentially can spit out a p-value. But just because you cranked some numbers and got a p-value doesn't mean it's the right formula to use. And it's, how to use the various p-value statistics formulas is really, that's probably beyond my knowledge. But we're going to cover at least one of them. You probably heard of it, the student t-test. It's somewhat illustrative in how it works because of the t-statistic, which will give you an understanding of how p-values work essentially. So the t-test is used to compare two sets of linear numbers from two different groups, like a test and control. There's a paired t-test where basically the populations are it's a before and after population, or somehow it's the same people having different effects applied to them sequentially, simultaneously. Well, I can't imagine one that would do it simultaneously, but if they are paired like that, then you use the paired t-test. The unpaired parametric is two different populations, but their standard deviations are equivalent. And the unpaired non-parametric is two different populations with non-equivalent standard deviations. All right, here is a study that was used, and a paired t-test was used to analyze between the ER blood pressure and home blood pressure. So you can see it's the same patient, it's just essentially a before or after situation. And here's this equation, and this equation does not give you a p-value. It only gives you the t-statistic, which we'll get into. So the average difference between the two groups as 19.5 millimeters of mercury systolic. So that's the number we plug in for the average difference. And since it is paired, the n is the same for both groups, 156. Standard deviation not given, but you can back calculate from the standard error, which goes into the confidence interval. It's 13.38 millimeters systolic. So our t-statistic here is 18.2. Put a pin in that. We're going to come back to it in a second. All right. So what is a t-statistic? It's kind of similar to the way the number of standard deviations away something is away from a mean on a bell curve. So if a t-statistic is 1, that means it includes 64.4% of the variance, and it excludes 0.316. So the P is 0.316. I hope that's explanative at all. So if your t statistic is 2, now you're starting to get into statistically significant country. That means that the out of the bell curve is excluded 0.044, which basically means this is the t statistic is helps you figure out on a bell curve how likely it is that the results you got were derived by chance and not by a genuine cause-effect relationship. T-statistic of 3, the p-value is 0.02. All right. So a t-statistic of 18.2 is a very small p-value, diminishingly small, which is, yes, less than 0.001. They're not wrong. The next thing is, should you use a two-tailed t-test or a single-tailed t-test? In general, two tails is the better test to use, because there are essentially very specific use cases that I never can commit to memory, but where you use a single-tailed t-test. The problem with using it inappropriately is that it will artificially half your p-value if you're not using it correctly. Basically, the long and the short of it is if your number is, if one of the limits of your number is potentially bounded, like it can't go below 0, then you can use a single-tailed t-test. But in almost every circumstance where something is going to cluster around a mean in normal distribution, it's not going to be bounded like that. So you should be using a two-tails. If you see a single-tailed t-test being used in research, they need to justify why they are using it. All right. It's very dense, but I hope it helps you at least sound a little smarter when you talk about p-values, which is really my goal for this class. If you have any questions, be sure to leave them in the comments, unless you're taking the course for credit, in which case be sure to email me. Also, don't forget to take the quiz in the show notes.